Okay, good morning, good afternoon, good evening, wherever you may be at this time, wherever you're joining us from, and welcome to AU 2021. Welcome to my class. This is Discovering the Mysteries of AutoCAD Raster Design. My name is RK McSwain. I believe this is my fourth year to present a class and my 18th to be an attendee at AU. I'm also one of the panelists in the Drawing from Experience series panel classes that will be in its seventh year, I believe, this year at AU. So we've been really successful with that, and proud that that's went on for 7 years. Just as a reminder, this class, as with most others, is being pre-recorded, and then during the actual AU time, we'll have some live Q&A afterwards. The panel class that I mentioned earlier will actually be live during AU, but being as this is pre-recorded, we don't stop for questions in between, and we're kind of limited to a time limit of 30 to 40 minutes. So it's going to seem like I'm rushing through some of this, but I want to be sure and cover all the material and go through all of the learning objectives. Just a very quick notes about myself. I've been an AutoCAD user since 1993. I worked for a civil engineering firm. We transitioned over to Sofdesk and then Land Desktop and ended up finally with Civil 3D in the mid 2000s. Around that time, 2005, I started my website, cadpanacea.com. Still going. And I was doing technical writing and functioned as the hot tip Harry for Catalyst magazine starting in 2009. Hot Tip Harry was the persona that presented the Lisp routines to all the readers back when Catalyst was a print magazine. And by the time I joined, everything was digital online. And finally, I was a charter member of the Autodesk Expert Elite in 2012 and still a member of that. So enough of that. Let's talk about why you're here. Hopefully you signed up for this class because you wanted to learn something about raster design. Raster design is one of the tool sets that comes with AutoCAD, such as the others are AutoCAD Map, AutoCAD Plant, AutoCAD Electrical, things like that. Most of the time, if I mention raster design to coworkers, colleagues, even experienced AutoCAD users, get a blank stare or a question look on their face. They've heard of it. They're not quite sure what it does, what it is, what it's used for. So that was kind of the incentive to presenting this class. I wanted to get some of the tools and knowledge out there about raster design. Hopefully we can walk away from this learning a thing or two. The learning objectives are, we're going to spatially insert some images, show you how to manage those images, look at some properties of those images after they're in the drawing. We're going to talk about editing and cleaning up those raster images. Most, or I should say a lot of the time when you get a raster image, it may be from a scan that was done in-house or from a third party. Those scans are not going to be perfect. So there's going to be some cleanup that's needed. We'll talk about how to do that. We will look at doing some raster to vector conversions, including OCR. Going back 20, 25 years, raster to vector has been a huge conversation piece throughout the industry. How do I take this scan drawing and make a CAD drawing out of it? There is no one button routine to do that on any application. Raster design has some tools to help you. It's not an automatic process, but we're going to look at some of the tools in there that'll help you do that. And finally, the last thing is there's a tool in here called Raster Entity Manipulation, REM for short. That's a really neat little tool that lets you operate on raster images as if they were CAD vector, vectors in a CAD drawing. So that's a nice little tool. We'll look at that. And as a final note, this isn't one of the learning objectives, but it's my personal learning objective that everybody attending this class comes away with something. So if you're a raster design power user, you've been using it for years and years, you probably won't come away with anything. You probably know more than I do, and maybe you need to be teaching this class next year. But hopefully like I said, most people that I run across, they've heard of it, they've maybe seen it, but they're not quite sure what it does, what it can be used for. And that's where we want to come in and illustrate a few of these tools and come away with something. So on that note, we're going to switch over to AutoCAD 2022 with Raster Design loaded. Let me just get that up here. So I've got a stock out of the box AutoCAD 2022. I've got Raster Design 2022 loaded. There's nothing that I'm going to do that has any customization on it today. I'm not even going to go through any of the option dialogues. I'm going to do everything straight right out of the box. Due to time constraints, we don't have really time to get into a lot of the options in some of the commands, but know that we're going to touch on maybe 1 or 2% of the entire suite of tools just because we are limited on time. So the first thing I'm going to do is just start a new drawing. And I have an image that I want to insert. So the tools are generally laid out in the order in which you might use them from left to right along the raster tools ribbon. The first one over here being insert. So I'll click that tool. It's going to load the splash screen, which loads up Raster Design. And after a second or two, it's going to give us a dialog that looks very similar to any other file dialog you might see in AutoCAD, with a couple of differences. One, when you select the image, you're going to see a preview of it and a little bit of information about the image here on the middle side on the right. And on the bottom, there are 3 insert options. One is a quick insert. If the image has internal correlation, or if there's a world file. A world file is just a text file that goes along with the image that tells any application, not just AutoCAD or Raster Design, how to place that image in the drawing. If either of those is present and you have quick insert checked, it will just insert the drawing using those parameters. Insertion wizard and insertion dialog are 2 more ways where you'll actually walk through a dialog to view and or change those correlation, that correlation data. So for this first one, we're going to use insertion wizard. The dialog is the same, except it isn't a next type of deal. It's just you make those settings in the dialog in your own order. The wizard is going to walk us through it. So I'll hit open. And you can see here, I have a drop down that lists my correlation source, either internally in the image or the world file. So in this case, there is a world file. It is nothing more than a text file with 6 lines of data in it that tell Raster Design where to insert the image, how to scale it, how to rotate it if necessary. So I can view this data here. I'll just hit next. And I'll look at this data, and this image is in meters. I will hit next. Nothing really to do here. I could change some of this data if I wanted to, but there's no reason to. It's already given to us through the world file. And when I hit finish, it shows up on the screen in the right location. So if you had other data such as parcels or roads or anything, if everything is in order, they will come in the right place. If I had other USGS maps, they should come in the right place based on their correlation data. So that was a pretty simple thing. You may be familiar with plain AutoCAD, and it has the Bing images that you can bring in. And there's other products out there such as Nearmap or PlexEarth, and those include these tools to spatially orient images. But for USGS maps or other data that you may receive from other locations, you may need to use the tools in Raster Design. I should note, if you have AutoCAD Map or AutoCAD Civil 3D, which is based on AutoCAD Map, those tools include other similar but not the same commands for inserting images and having them come in the right place. So let's move on to our second learning objective, and that's going to be cleaning up and editing images. I'm going to exit out of there, start another new drawing. And this time I'll insert a different image. I have an image here. And this time I'm going to use quick insert because the image I'm about to insert has no correlation data. It's nothing more than a scanned drawing. It was probably scanned 20 some odd years ago. There's nothing about it that tells me where to place it in the drawing or anything. So I'm just going to say quick insert. It's going to drop it in at 0, 0 coordinates, and it takes me right to it. And you can see the UCS icon down here at 0, 0. So this is a scanned image. One thing I didn't point out on the previous drawing was this button next to, it's in the Manage and View panel in the ribbon. There's a drop down that shows you all of the loaded images in this drawing, and right next to it is a button, and it opens this image manager. The image manager has 2 drop downs inside of it: image insertions, which shows you all of the images that are inserted in that drawing, and image data. This is the one that's probably most useful to you. You can click on the image and see more information about it below. And the one thing I want to point out about this image is it's bitonal. And bitonal means that every pixel in the drawing is either on or off, 1 or 0, black or white. There's no colors, there's no nothing to it. If we zoom in really close to this image, and I'll go to some of this text, and you can see if we zoom in, it looks like a video game from the 80s. You can see all the little individual pixels. It's a really poor scan from, considering where we are today. But at the time this was scanned, probably 20 years ago, this probably wasn't terribly bad. And if you zoom in, as I'm panning around here, you can see that you can make out some of this text, but it's really not that great a quality. Every single pixel in this drawing is either on or off. The on being white, off being the black color. I could reverse those colors and make the black white and the white black. Same difference. There's no other colors or anything in this drawing. And most of the drawings that we're going to touch today are going to be bitonal. And that's what you'll get generally when you scan a drawing on a large format scanner. So I'm going to close the Manage panel. Look back in this drawing, and you can see it's got a lot of noise out here on the borders. It's got some other stuff. I don't care about this title block. What I'm really interested in getting to is this graphical data representing this cul-de-sac, these lots, this easement, this reserve, and this easement around what looks like a drainage ditch over here. So we'll zoom out, get it on the screen. And you may be tempted to reach up and hit the E key for erase or something like that. Remember, this is a single raster image. There's nothing vector in this drawing at all right now. There's 0 that you can do with plain AutoCAD tools other than erase the entire drawing. So we're going to go up here to the Raster Tools tab in the ribbon and go to the crop, which is in the Edit panel. And I'm just going to crop a rectangular region. And when you draw a rectangle or when you're erasing or doing things like that in AutoCAD, you normally pick 2 points to define your rectangle. Here, the rectangle selection tool is a little different. So I'm going to pick my first point. And if you see on the command line, it's asking me to specify an angle. So the first thing you do is tell it the angle, and then it'll let you draw your rectangle. So I basically want to crop out this drawing, and that took all of about 15 or 20 seconds, and most of that drawing is gone now. I don't need the rest of that raster image. There's still some data up here. There's still some miscellaneous data here. I don't need this title block. So what can we do there? Under the Remove drop-down, again, I'm just going to use a rectangular region and start removing. It's just like the erase command in AutoCAD, except remember, this is raster data. You can't use erase on it. You have to use these tools that are in Raster Design. There's some miscellaneous data in between the lots, and you see there's stuff here. And anything that's picked up on the scanner, when it's scanning to a bitonal image, if it's more than 50% gray, it's going to make that pixel 1 or on or black or whatever you want to call it. In this case, it's white because we have a black background, but anything that is more than 50% coverage at the time of the scan is going to become data in the drawing. That's why you have all of these areas that it looks like someone just scratched on it with a pencil or something. And that very well may be what it was. There could be some marks on the drawing, just anything during the scanning process. The quality of the scanner, the DPI of the scanner, all go toward determining how this data is interpreted. So let's jump over here. We want to get rid of all these little dots. So we can go to this cleanup tab, and there's a tool called despeckle. The first thing it asks you is, what part of the image do you want to work on? Well, let's just work on the entire image. Now, the next thing it asks is pick a speckle to set the size, or I can tell it what size in pixels, what size in units. Well, I don't know anything about the pixels or units of this drawing. I just know I want all these things gone. So let's start with this one. I pick, and notice a lot of the speckles turn red. That's to let you know that's what it's going to erase. Well, notice it missed a lot of them. And it also tells me down here on the command line, that's a pixel size of 5. Let's go a little bigger and get some more of these. So I'll say respecify, and this time I will say size in pixels and maybe go 6. And it grabs some more of them. Let's try that one more time, and let's say pixel size of 7. That looks a little better. It's missed a few still, but look what happened now. It picked up our foot sign on these dimensions, a foot sign over here, some periods in here. That's probably not what you want to do. So let's go back and revisit this command. And this time we will say, let's define a polygon for the area we want to work on. And we'll skip some of this text. We'll go around here. And if you remember, we were working with a pixel size of 7 earlier. And so I'll just define 7 again as the size I want to get rid of. The speckles rather turn red, all the ones it's going to erase. I hit enter and they're gone. Now I could have just used the remove command, but think of how long that would have taken to go through there and do what I'm doing right here, getting rid of them one at a time. There's still some more out here we can go get rid of, but in the case of time, we're going to skip over that. And my drawing is fairly clean now. We have a dimension on here of 791 feet. Let's measure this and see how long it is. Just eyeballing it. And it's actually only 7.7 units long. Feet, inches, whatever that is. I'm going to call it feet. I know this is feet marked on here. How can I get this drawing up to scale? Well, let's do one thing real quick. Let's jump over to the units command. We'll change my precision and my unit type. Hit OK. And I'm just going to draw a line. Doesn't matter where I start it. I'm just going to start it right here. And I want to draw it this length in this direction. So I'm going to say at 791.06 angle. Note the dimension on the screen in that scan is southwest. I'm going to go northeast. So I'm going to say north 87 degrees, 54 minutes, 59 seconds east. And just so we can highlight that line on the screen, I'll change the color. And you can see that line is actually 791 feet, and it's much bigger than our scan. So if you're familiar with AutoCAD, you're probably thinking I'm about to use the align command, but there's a tool in Raster Design that's a couple of steps shorter. It's called match. So I'll click there as my first point. Then I'll choose the endpoint of this line. I will click the endpoint of that 791 foot line, and I'll grab the endpoint of our actual line, that's 791 feet. And it scales up the drawing, rotates it, makes everything line up. So now that's 791.06 feet. Remember, this is a scan drawing. So when it was scanned, if the humidity had affected the paper, or the paper got slightly jammed in the scan or anything like that, this raster image is never going to be perfect. If I do a distance down here now, this says 240 feet, but let's measure it actually, and it tells us it's 243.29. So you're never going to be exactly perfect, but at least we're in the neighborhood now. If we're just doing an exhibit, that's probably good enough. And the last thing I will show you is we're going to insert the regular Bing image from AutoCAD into this drawing. and see how well we did get it to scale. And here's our map. I happen to know where I want to go here in lat long. I'll enter that in the address bar. It takes me to approximately where I want to be. This cul-de-sac right here is the same one as the one you see here on the left side of the AutoCAD screen. So I'm going to drop my marker approximately in the center. I'll hit next. The screen here takes about 9 to 10 seconds to load up all the coordinate zones. So I'll try to make this time go by a little faster. And there it is. I know my zone is TX83-SCF. I will select that, hit next. And I will come in here and pick the approximate center of this cul-de-sac, angle of 0, and wait about maybe 3 to 4 seconds for the imagery to load. And there it is. We have our road Huffmeister here, Covesville right here. We have our easement. We have our sewage treatment plant inside of this reserve, line work for this ditch, and so on. So if I were generating an exhibit, we've been in this for about maybe 15 minutes, and there's not one single vector, line, or entity in this drawing at this point. We're all working with the raster image we started with and the imagery from the geolocation command inside of AutoCAD. So let's move on to our next item. I'm not going to save this drawing, and I want to point out this screen here. This is asking you whether you want to save the image. It knows I have made some changes to this image. Remember, we removed all the speckles and we cropped it. Now it's asking me if I want to save it. This is something you probably haven't seen in AutoCAD. So in this case, I'm going to say skip all. I do not want to save any changes to that image because we're going to use it later. So I'm going to start another new drawing. And we'll come in here and say insert. And this time I have a saved version of this drawing that's already been cropped. And it's already been cleaned up. And we're going to talk about raster to vector now. Again, there's no magic one button that's going to convert this entire drawing to, or I should say this entire scanned image to an AutoCAD drawing. There are some tools that can help you though. They are under the vectorize and recognize text panel. And one thing I want to turn on is the raster snap. Raster snap works like object snap, except it does snap to raster entities in the drawing. So the two I have enabled are center of the raster line and end of the raster line. And I will go right under primitives and choose line. And I hope this comes through on the recording. Once I select a line in the drawing, and notice these are dashed lines, it still should do a fairly decent job. That one actually didn't. Let's try this one here. That one picked up the entire line. That one did. That one did. I'm simply picking the raster entities and it's drawing a line underneath. And when I get done, it's going to erase those raster lines and give me the vectors. And you can see this one didn't complete. The others did. I didn't actually choose this one here. The same could be done on this arc. I will remind you, we're working with raster entities. If we zoom in, just to remind you, these are pixels. They have no geometry associated with them at all. The fact that Raster Design is converting them to vector lines is purely done by intelligence in the software. It doesn't know that these series of pixels form a line. It is just figuring that out based on the intelligence built in to the software. So we're going to pick this arc and see what happens. I generally have had about a 1 in 10 chance of getting that arc. That time it picked it. You can see as I pan, it shows you the vector arc that it drew. This arc here, you can tell this isn't a straight line. It is never going to pick up that arc. You can pick on it all day long. It's just too flat of an arc. So that's something you would have to go over and draw yourself. Again, if I do the line, I can probably convert that one more line out there. And so the rest of this, I would probably have to convert manually, but it's a start. We don't have time to do this whole drawing, but I could probably vectorize this whole drawing in 15 or 20 minutes using these tools. There's another piece to this under the followers drop down here for polylines and contours. And I have another drawing that I'll load up. Again, a blank DWG file inserting a raster image. Another one of these images that has a lot of speckles or noise in it. I don't care about any of that stuff, so I'm going to use crop. I'll define a polygon around what I'm interested in. And there we go. We've done a lot of cleanup right there. So you'll see I have some contours here, starting with elevation 498, 500, 502, 504, 506, and so on. I have not done any setup on here. There are some setup parameters that I could use, but again, I'm going through this right out of the box. I'm going to pick this contour right there. And hopefully the blue highlighting comes through on the recording. You can see it picked it up. That elevation is 500. So I'm going to hit enter. I'm going to enter my elevation of 500. I'll repeat this. Actually, I'm still in the command. 502, pick the whole thing up. Next one is 504. And this time it did not go all the way around. I wonder why. Let's look in here. Remember, Raster Design is following these pixels along using its intelligence, but it gets here, it's at a dead end. It does not know to go back and circle around on this set of pixels here. So what we can do is say roll back. I can roll back to this vertex, and then I can start clicking a couple, and at this point say continue, and it's going to go all the way back to the other end where it should be. That's 504. Let's look at the 506 contour because I know it's going to have a problem too. It stopped right here. It doesn't know what to do when it got to this 0 that's overlapping the line. It doesn't know whether to follow this around, keep going this way. So again, I'm going to say backup, which is back up one step, and then I'll pick my next point and then say continue. It takes us all the way around to the other side. I'm still in the original command at this point. I haven't exited the command. So this time I'll hit enter and give it an elevation and then hit enter once more to exit the command. And now you can see that I have a raster image, but I also have some vectors in the drawing. You can see all of the grip points on them here. And if I transition into a 3D view, you can see it's actually putting these polygons in 3D. Now I actually have a completed drawing that I converted all of these, and you can see it's a very steep, short hill, but this is all 3D. You could drop it into Civil 3D or whatever civil application you have and make a surface out of that data. That probably took 15 to 20 minutes again to take all of the original raster contour lines and convert them to that drawing. I want to run into our next topic here, and that would be the OCR, optical character recognition. This is going to take raster text and convert it into actual AutoCAD text. So on the vectorize and recognize text panel, there's OCR. Again, I'm not doing any setup. I'm going right into the command. It asks for the first corner. It's going to ask you for the angle, kind of similar to when you're selecting a rectangle earlier. And it doesn't have to be perfect, just eyeball it out. And then it asks you to complete the rectangle selection. As soon as I click the next point, Raster Design is going to analyze what I've selected and convert it into text. This will take about 2 to 3 seconds, and you see it on the screen here. If you're selecting a giant page of text, it could take much more time, so be patient. It's not a super fast routine, but it does do a pretty good job. So you can see it's converted my text. I'm going to zoom in a little bit. This is the image. This is, I'm sorry, the top panel is the image. The bottom panel is the text it converted it to. So anything in yellow is what Raster Design is saying, hey, I'm not quite sure this is right. You might want to take a look at it. Well, the V is right. The M, it converted it to an N. That's easy enough to fix. Well, you probably can't see it, but there's periods behind HCMR. So I'm just going to go ahead and clean this up a little bit. Put a space there, period, period. Whoop, not that many periods. I'll make an M there and an R. Close this off and hit OK. When I hit OK, it's going to create some giant text on the screen. Again, I didn't go through and change any settings due to time constraints, but it's going to create actual text. And it made it ginormously large. You can see it right here. That's fine. We can go over here to properties. I have no idea where it came up with the 12,000 units to hide, but I'm going to make it about 0.14. And yeah, it's on the screen. Aha, here it is. So maybe it does need to be a little bigger, maybe 1.4. You can adjust the size, but you can see the end result is we have actual AutoCAD M text at this point, not any of this raster text that isn't editable or anything. So again, if I wanted to remove this, put the other one in there, it's just that easy. So size is probably still a little, there we go. So we're running up on our time limit, and there's one more piece of the last learning objective I wanted to go over, and that is the raster entity manipulation. So let's start a new drawing. I'm going to bring in this same raster image again. Quick insert, it's going to drop it right in. So again, because of different scanners, different methods of scanning, the quality of the paper or Mylar or whatever it is, you're going to have different varieties in the scan. Some of this text you can see, this looks like it's at a much greater angle than this text above it. Not sure why. I don't think it was printed like that. This text here, though, was a stamp. I happen to know that. And let's just say we want to clean that up and make it parallel to the sheet, not at an angle. So raster entity manipulation is this panel right here. Very quickly, I will go up here and define a rectangular region. Notice it turns everything red. At this point, I can use any AutoCAD, most any AutoCAD editing tool on this. I'm just going to use the rotate command. Grab it, hit enter, pick a base point. I happen to know that I want to go -3 degrees. Type that in. Now the text is parallel to the sheet. I will use the middle button of these three right here. So there's 6 buttons over here. I'll use the middle one on the left, which is merge it back into a raster image, pick it, and boom. I haven't changed anything about the drawing. I only use the rotate command on a piece of this image. So that's pretty cool that you can grab some raster data and do just about any AutoCAD command on it. And really quickly, I will come over here, repeat this exercise, because as you can see, this E in the parenthesis of this note is interfering with the line work of this drawing. So I will zoom out, grab that. It is now a REM object. I will use my move command, pick this, move it over. Now it's clean. Remove it, put it back in the raster image. Again, that's back in the raster image. This is just like something you might do in Photoshop or something like that, but you're able to do it right inside of AutoCAD. I need a little cleanup here, so I will grab my rectangular region, do a little cleanup. Again, I'm just eyeballing this. Nothing magic about it. That looks a little better, but I'm missing a dash over here now. How can I fix that? I can use my REM object again. Grab an existing dash, use the copy command, bring it down right there, merge it into the drawing. And then to get rid of the one I selected is the upper right toggle, pull down, and I'll say clear all. Now we've put that extra dash back in. And the very last thing I will show you about This is not actually REM. This is more about converting vector back into raster. Let's say I was cleaning up an area over here and I accidentally got rid of the dashed lines that went in this area because I just was not paying attention. I didn't catch it till later. How can I get this back? So what I want to do first is just clean it up here, remove a little bit more of that one and that one. And there's two different tools. There's a touch-up tool where you set the cursor in pixels and you can see the box is growing as I zoom in. It's roughly the same size as that line. This one is very tricky because it's kind of like the sketch command in AutoCAD. You pretty much have to be a good artist to get this in here, but that's not terrible. That's not great. So let's get rid of that and let's show another way of doing this. I'll get rid of those lines. And this time I'm just going to draw a regular AutoCAD line from roughly right here to roughly right there. And then I will go in and break that with some breaks to make it look like the dashed line we want it to look like. But that's still a vector. Those are 5 different vectors. How can we get that into the raster image? Let's look at the raster pen command. I drew those lines in white. I've already set up white to be 4 pixels wide. That's good because I know that these raster lines are about 4 pixels wide. And then I will come in here and say merge vector, pick those 5 vector lines. Do I want to erase the vectors after I merge them in? Yes. And there we go. That's a little better way than the trace command to get those lines back in the drawing. So we're really up against the time now. I wish we had more time to go over some of these things. The very last thing I will show you just real quick is if you're zoomed into a raster image, notice this toggle here, shift plus left click, select. If I have some line work, some vector line work, and I'm in here working on it, let's just draw something random. And I'm selecting it and I want to select the image. You may know that you can't normally select an image unless you come out here and grab the image frame. But what if I don't want to zoom for whatever reason? If you have this toggle checked on, you can use the shift key and select a piece of the raster, and now the image is selected. You can see down here on the command, it says 1 image found. The downside to having this on all the time is if you're, say, editing some vector lines, let's say I erase all this, but I want to remove this one line. Now, when I use my shift left click to remove this line, it actually selects the image instead. So in that case, you would need that turned off, and your left click plus shift would actually remove that line from the selection set. So be aware of this toggle. It can cause some confusion, especially if it's on and you're not even working in raster design. So that was the last thing. And in summary, you know, we're really short on time with these sessions, but I hope we're able to show you some of the tools that you can use for raster or use in raster design. Again, we've just barely touched on very few of them, but hopefully this will jog your creativity and you'll want to get in and explore some of the other tools and things you can do in here. So, and say thank you for attending this class. I hope the rest of your AU is very productive for you and appreciate your attendance. Thank you.